know yesterday you guys were kind of brain fried after the PSAT, so let's try to go ahead and make today as productive as possible. If I were you, I'd have a different colored pen out for any like quick little notes I say about the test. You can write them down and have them as you're studying tonight. That would be a good idea. Maybe a highlighter out might be good too. As I talk about different types of problems, you might want to highlight certain things in your notes about like, ooh, make sure to look at all good things also for tomorrow. There is a test review. I'm going to give you guys just 1 second because I talked to my seniors already because I had them yesterday. Let me unfreeze the screen really quickly. And their test review, but some of you guys did not get to write them down. I did change up something just a little bit on the test review. It was worded weird, and I didn't like how it was worded, so I apologize for that. No one's turned it in yet, which is good. But on the test review before, I said other good ones. I don't know why. It was from a couple years ago, I think, and I just forgot to change it this year. The other good ones, you need to study them for the test tomorrow. But remember, on the review, do you have to write directions or problems? No, save time. Save time. You don't need to write directions or problems. But you do want to work through these examples. So if anyone wants to take a picture of it real quick, I might not give you time to write it down right now, but just a few of you. Oh, that was last night's. Hold on. Which one am I looking at? Oh, I'm sorry. Let's go back real quick. I meant to be talking about the review. Let's go to the instructions. Now we're good, right? Thank you. Okay, the other good ones, I think it started somewhere around here. It was in the 30s or the 40s, and I put other good ones. It was awkward. I don't know why I did that. It's just the whole set, but no directions, no problems. Maybe you can write it down quick. The reason I'm giving this to you is some of you are like on top of 2.6, you're on top of 2.7, you're like, give me a book and let me review this class. I don't mind. So if, not just the seniors, if there are some underclassmen too, they're like, no, I'm on top of things. I know what's going on. You might want to go run and grab a book right now. I don't mind, no judgment whatsoever. It's actually a good thing. If you want a book to be working on the review during class, you can grab out your book. You can go grab one of mine at any point during the class today. If you're like, this isn't helping me, I just need to practice, go grab a book. You can be working on it. Totally fine. Go over there. But we are going to go ahead and right now go to section 2.6 and grade. Okay? Go to section 2.7 and grade. And then we're going to go ahead and recap on the test. So those of you guys that are working, I might just draw your attention back to the class for a second and be like, wait, pause, everyone listen. Whatever you're doing, just be listening to that, just in case I do that. But right before we go to grade, you guys wrote down the key information to 2.7. In class 2 days ago, I did this example. Nope, I did not do that one in class 2 days ago. I did this example saying, hey, this is the big idea of 2.7. The big idea is if you have a polynomial not equal to a number, not equal to 0, but less than or greater than, less than or equal to, greater than or equal to. The long story short is we need to get these things called key numbers to put in a sign chart with intervals like we did with graphing. Pick a test x just like we would do with graphing, but instead of graphing the points, just ask yourself, if you plug this in, the beginning problem, it's not the key numbers with the inequality, is it the answer, or it's to be disregarded? Plug in the test values to the original, true or false. So what the notes were that you guys were just writing down was telling you basically not just for a polynomial, but also for the example that was done on the video yesterday that some of you might want to check out. It was hard for two reasons. One is it's a rational function, not just a polynomial, so we're not just looking for zeros with the key numbers. If you look at your notes, polynomials, just the zeros are our key numbers. Rational functions, the zeros and the undefineds, aka the zeros at the top and the bottom fraction. That was hard, a little bit trickier with a rational function, but also there wasn't a zero. So we had to do this little manipulation or transformation of moving whatever was over here to the other side to get our zero. Now, okay, now we're ready to go. So whether you have a polynomial or whether you have a rational function, you want to get 0 on one side first. We had to do a little bit of common denominator to get a nice fraction. Then we found key numbers, zeros and undefineds, which would be 8 and 5. We made our intervals 8 and 5, and we just picked test numbers, plugged in, and said true or false. You could plug into either one. And in the video, we talked about how the or equal to made a bracket on the 8. The 5 would never have a bracket because it was a DNE point, and we chose the true intervals, however many there were, as our answers, and we were done. That's the big, long story short of section 2.7, inequalities of rational and polynomial functions, or I should say inequalities. Polynomial, rational. So making a sign chart, picking test x's, and asking true or false. That ends chapter 2 for us, and that brings us to section 2.6 and 2.7. We haven't been able to do the evens because I didn't want to do that on the video without you guys yesterday. I guess I could have, but I guess I also kind of assumed that at least a few of you would not look at the video, even though I told you to. So let's go ahead and section 2.6, if your homework spiral is not already out. If you don't have it ready, I guess you could watch us, or you could play with the test review. Or you could be working on the homework, or you could be highlighting in notes. But if you do have it ready, let's go ahead and grade. Okay? Number 2 is a vertical asymptote, section 2.6. This was the one due a long time ago. But you guys only had to do half. Then you were finishing it up with the sketching. Number 8, guys, it looks like there's tons of work, but there really wasn't meant to be tons of work. This was the behavior near the vertical asymptote, and the long story short, if you use the notation, there's the snazzy notation for what's going on. From the left or from the right, from below, from above, this vertical asymptote, and from the left, from the right, from below, from above, this vertical asymptote. So from below -2, the graph is falling. From above -2, the graph is rising. From below 2, the graph is falling. From above 2, the graph is rising. You could have used words, or you could have used notations. You didn't have to write out your huge tables. That's okay. And if you guys want like an actual little picture of what's going on, if that helps your brain just a little bit. This was where we plug in like 1.9 and 2.1, etc., etc. Just to help you out with the picture. This would probably be easier if you got it wrong or if you got stuck. It'd probably be easier to write this down for you to check the answers later. Coming towards -2 from below, down, from above, up. And then coming towards 2 from below, down, and from above, up. Just have to figure out a way to put that in words or to put that with the notations as far as the answer. But that's what both vertical asymptote behavior looks like. Lauren? Yes, you may. Okay, number 12. Let me give you guys a second. Domain, everything but -3/2 or -1.5. Vertical asymptote is there because it was non-removable. It did not reduce away. Horizontal asymptote. Top wins, bottom wins, or tie? Oh, I don't think it'd be that hard. Top wins, bottom wins, or tie? Yeah, remember the degrees are tied. So tied, ratio of leading coefficients, -7/2. Number 22. I showed a little bit of work off to the side as to how they got the 1/3. I remember last year they got a little stuck with the 1/3, finding the x-intercept. But number 22, this was one of those big ones where you're putting everything together. It was like the example that we did 2 days ago, where you check the domain, everything but 1. There's a vertical asymptote there because this does not match up with that. They are different if you put parentheses around them. So that's a vertical asymptote at the 1. The intercepts we plug in when x is 0, when y is 0. Quick reminder, when y is 0, we have to multiply up. And that's why the intercept is 1/3. The y-intercept was a lot easier to solve for. Top wins, bottom wins, or tie for the HA? Tie. So ratio of leading coefficients is 3. And then guys, we would have done a much better sign chart than they did. They just plugged in random numbers and were like, hopefully that's good. We would have done our sign chart with the intervals. I'm going to model that just this one time on this one problem. I'm going to model that just this one time because I know that their sign charts, their tables are kind of weird and eclectic and random and blah. So if I were you guys doing a table with all this information, in our system that we talked about in class, there would be 3 rows. 1, 2, 3, right? We have our intervals, our x, our test x value, and then our f of x value. So section 2.6, we're getting points to put into our graph. Our intervals would be using our special x values, which is 1/3 and 1. So I would have done negative infinity to 1/3, 1/3 to 1, and 1 to infinity. Did anybody have any test values they plugged in, just so I'm not just doing random things off the top of my head? What did you guys plug in between negative infinity and 1/3? Yeah, that's what I would have done. This one's a little bit nastier. I mean, I guess you could do 1/2 or 2/3. I don't know which one's easier. Maybe 2/3 because there's a 3 up there. And then, what did you guys think? Yeah, that's what I would have done. And if you plugged in 0, wait, oh, that's an intercept. Haha, we already have him. Sweet. 2/3. All right. Would have had to go plug him in. 3 times 2/3 just ends up being 2 minus 1, which is 1. All over. 2/3 minus 1, 2/3 minus 3/3 is a negative 1/3. It's the reciprocal. A little bit of work. Hopefully you got negative 3. And then at the point 6 minus 1 is 5. 2 minus 1 is 1. There we go. And those could have been your extra points that you put into your sketch. Remember, when you sketch, you're putting together everything. So you're putting together your horizontal asymptote, your vertical asymptote, your intercepts, whichever ones you know. You'd have an extra point here. You'd have an extra point here. Maybe you would have been a little stuck because you only would have had one of these points, but if you knew the horizontal asymptote, the function had to get closer and closer. And you knew the vertical asymptote had to get closer and closer. You could have checked the behavior if you wanted. What was going on at point 9, positive or negative infinity, would have been negative infinity. What's going on at 1.1, positive or negative infinity, would have been positive. You could have double checked, but swoop, swoop. There it is. You know how I said I might give some hints about the test tomorrow? If you have a colored pen or highlighter, you might want to highlight this problem. I'm not saying the exact problem is on the test, but just saying, you might want to highlight them. Sketching a function, identifying different characteristics, and seeing if you can put it all together is a great long answer problem. Did we do an example, at least one in our notes like that too? Of sketching a big ol', yeah. So you can go look at your notes also for the example problem. And I bet there's going to probably be one in the review also. Guys, 42, 43, 44, A, C, B. Something was weird in the back of the book. Something might have been weird on CalcChat. I would grade that real fast. A, C, B. Number 60. If you want, you could highlight this guy too, although he's a little bit harder than the last one. Because he's another do all the, identify all the different key stuff and then plug in. He's a bit grosser when you plug in though. I'm not sure I would have made that same table, but I already showed you how I would do a sign chart. I reminded you, I should say. So remember, I wouldn't have done that table necessarily. I would have done a table with, let's see, what are my special x's? Just 2? Oh, wow, just 2. So I would have done negative infinity to 2 and 2 to infinity. I wouldn't have gotten near that many points if I had done it my way. Why is there a slanty asymptote? First of all, what's the horizontal asymptote? Why is it not there? Top wins, bottom wins, or tie? And whenever the top wins, none. But if the top wins by 1, then we go find the slanty. How on earth did they figure out that slanty one was this guy? What happened in between here? Long division. And they ignored the remainder, just like we talked about in section 2.6. Throw in some extra key points. Graph your vertical asymptote. Graph your slant asymptote, the line, 2x minus 1. Intercept of negative 1, up 2 over 1. Dotted. Get your extra couple points in there. There were no intercepts. Well, actually, there was a y-intercept, sorry. There wasn't any x-intercepts because it can't possibly hit. But get a couple extra points, and hopefully you guys knew to swoop it. Swoop it. There it is. Swoop it, there it is. And I think, Salma, that was your question a couple days ago, right? Number 60? Yeah. So he was messy. His numbers weren't nice. But maybe the ideas made sense. Hopefully the ideas made sense. And number 80 is, I think it's the last one, right? True, true, false? True, true, false? True, true, false. I think it was just asking whether or not it was possible, talking about vertical and horizontal asymptotes. Guys, section 2.6, I'm not going to spend a lot of time, but is there something that you guys want me to look at or explain or clarify? You all right? This is the one from a few days ago. Okay. Okay. We went over a lot of different things in class, so I was hoping that we would be generally okay. So let's go peek at 2.7. Probably more worried about, and I understand that. So 2.7. Just out of the notes you took down today, that should have already been in there. The vocab for number 2, both of them were in key numbers, and then test intervals. Number 12, what math had to happen? Some of you might have gotten stuck on this, like where to go. What math? Common. We had to make common denominators. How do we make common denominators? Multiply that guy by him, multiply this guy by him, and then they were able to put it all together. And after that, it was just distributing, not killing seals, combining like terms, factoring. And then the zeros are the guys on the top. The undefines are the guys from the bottom. And the key numbers would have been all 4. The 2 guys from the top and the 2 guys from the bottom. Guys, remember, this isn't a video, so if you need any longer time with any of these solutions, you can check them out tonight. Or obviously you can come in. I'll be here today at least until 3:30. But I'm also here during period 7 and during lunch. Number 30, he was a bit easier as far as key numbers. He had a GCF. Pull out that GCF. The only zeros are 0 and 3. So then, in my chart, I don't like how they do it. In my sign chart, I would have had these intervals. And we would have ended up with, let's see, hold on, plugging in. We would have ended up with false, false, true. False, false, true. He was the only true guy, so he's my final solution. The number line is just them reminding you, like, hey, you can actually graph this on a number line. But you guys probably haven't ever used the parenthesis on a number line before. What's another way of showing the bounded by but not equal to? Open circle. Yeah. So most of you are used to the open circle arrow. That's okay too. They use the parenthesis, like parenthesis bracket arrow. Either way. You can do an open circle arrow or a parenthesis arrow. But that's the correct interval because he's the only guy that was true in the sign chart. This guy, he was a rational function. So remember, one side is not, oh, sorry guys, struggle. One side is not 0. So like the example that's on the YouTube video from yesterday, we would have had to subtract that guy to get the 0. And then maybe from number 12, you guys see common denominator work happening. Common denominator work to get your fraction. 0's on the top, which ends up being negative 14. Undefines, or DNEs from the bottom, 6 and negative 2. Those are the numbers that need to go into our sign chart, intervals, and test. And at the end of the day, the only true ones ended up being this guy and that guy. There are no brackets because there's no or equal to in the inequality. There are no brackets because there's no or equal to. So the DNE can't be allowed and the 0 can't be allowed. And I think, oh, there's one more. I'll give you just a second if you want to write down in colored pen the correct answer if you know you don't have it. It's also on the YouTube video that we posted tonight. Or I should say by lunchtime, probably. Number 66. He's actually easier than the last guy. Except, was he a domain problem? Does anybody have that section of homework close? Was he under a square root to begin with? Okay. There's not going to be any square root domain problems tomorrow. So this is one of those I'm trying to show really quickly because he was kind of harder. Whenever you have square roots, the domain says the underneath part has to be greater than or equal to 0. So I like this problem. Like this would be a great problem to study for tomorrow. But the whole having to think about the domain to get here, that's not going to be tomorrow. Okay? The whole domain part to get here, that's not tomorrow. But solving something like this could be a tomorrow. Could be a tomorrow. So if I were you guys, I would grab out your highlighter. I would highlight number 66. And I would say the inequality is good to study. What happened with the inequality is good to study. But the whole domain, like having to make this jump and figure it out by yourself, that's not going to be necessary. The domain part isn't necessary, but the inequality in solving it is a great thing to study for tomorrow. At the end of the day, your key numbers, the 0 was on top, 0. The bottom, the undefineds, were plus or minus 3. So made intervals in the sign chart with those. When you tried true or false by plugging in and asking yourself true or false, these two ended up being true. And this is very similar to the example in the YouTube video. The bracket is on the 0 because or equal to 0. The parenthesis is on the 3 because it's an undefined. It's not allowed to equal anyway. I've tried to speak kind of clearly with details as to how these problems are solved because I realize just by the nature of some of you just kind of tuning out after the PSAT yesterday and not deciding to do any pre-cal last night or not deciding to go into section 2.7, not deciding to watch the video. I realize some of you need to go watch this tonight. So I tried to explain the evens to the homework problems because some of you frankly weren't ready to listen to them. But if you watch them tonight, hopefully it'll help you after you've had time to play with 2.7. With that, kiddos, those of you that were tracking with 2.7, is there anything else that you want me to talk through? Odds or evens? Priscilla? The number lines? No, I don't think so. Double checking real fast. For the inequalities, just in general, section 2.7, there's going to be one multiple choice, one long answer. One multiple choice, one long answer. The long answer, you're just showing me all of your work. So if you end in the intervals, that's great. You don't have to do the number line. And the multiple choice, if there is a number line, it'll be drawn for you and you're just making it match. Is that okay? Okay. Any other questions, Matthew? Meaning it wasn't a 0? Like it was an undefined? Oh, it's like a 4 or a 3 or something like that. Bracket or parenthesis. Let's go back to this one real quick. Negative 14 was the 0. It's what makes this whole thing 0. So I would call this guy the 0, and I did that in the video yesterday. You might want to listen to that example. It's a little bit better explanation. But because we don't have a better one in homework, this one is greater than, not, or equal to. Let's imagine it was or equal to. Okay. This is a 0. He's from the numerator. These are undefined, discontinuities from the denominator. These two will never have a bracket on them in any scenario, regardless of that, because they're not allowed to exist. So these will have parentheses in all of your intervals, even in the answers. The -2 and the 6 have to have parentheses. If this was an or equal to, the 0 would have been included with a bracket. So the -14, if it was an or equal to, the number that makes this 0 would have been in a bracket. So down here in this example, when you see the bracket isn't because the number is 0. The bracket is because the number that makes this 0 is allowed to be included. Does that make sense? So if this was like an x minus 1, and it was a 1 instead, it would still have a bracket. It's still the 0 that's allowed to be included. Does that make sense? Okay. So it's not about this guy being 0, it's about him making it 0. That's why he's included. Good question. Anything else from 2.7? Okay. That video is going to be posted. You guys will be able to access it, but let's go ahead and let me go to the review. Let's see. Chapter 2 review. I'm going to pull it up on the screen for those of you that weren't ready to look at it just a second ago. Maybe now in your homework spirals you are ready to look at it, like what the assignment is. Just a few of you might want to write that review down. I'm also pulling up the review over here for us to look at. Let me move him so you guys can see the whole assignment. Nope, I don't want that. There we go. Just a couple of you still need to write that down. I am going to ask my seniors in just a second if they have any questions on the review from yesterday. Let me just close out of that because that's in my way. But I'm going to actually use the problems on the review to kind of be our guide as far as me helping you guys think through the types of problems that'll be on the test tomorrow. So I have 1, 7, 9, 15, 17. Let me come over here and let's go ahead and look at what some of these problems are. Okay, so going back to the very beginning of chapter 2, you might want to be in your notes and like highlighting things in your notes if you want. You might just want to be like on a page at the very end of your chapter 2 notes and just write down like the key types of problems I say, because as we go through a section as far as the exercises you'll be doing tonight. Oh, well that wasn't helpful. Thank you. Okay, give me a second. Getting back to the review. You can either be in your notes trying to highlight section by section, or you can be the last page of your notes writing down the key topics for tomorrow. I'll give you a couple more hints as far as multiple choice long answer. There is no calculator. We've said it a couple, I've said it a couple times, no calculator tomorrow. Real quick, as you guys are getting set up, and maybe as the last couple of you still want to write down your review exercises, walk through tomorrow. You come in the door, what's the first thing you should do? Put your phone away. Don't even go to your desk. Just put your phone right in. Make sure the sound is off. Okay? Then, as you walk in the room, even before you go to your desk, what would be a good idea to do? What's up here? Turning in your composition book, or your notes first, and then your homework spiral, go second. You've been in 10 seconds and you're already halfway ready to get your test. Does that make sense? Phone up there. Notes, wait. Please get 100% on your notes. What do you need to do with your notes before tomorrow? Update your table of contents, section titles, the section numbers, the page numbers. Please don't lose points on your notes. If you've been absent, make sure you've gone online or you've borrowed notes from a friend or had them send you pictures. Fill in your notes. So your notes need to be here, homework spirals need to be here. Then, as you head back to your desk, what are you going to have out? Pencil, cover sheet, scratch piece of paper, and then you're ready to go. If you're claustrophobic, is there room around the room to spread out? There's a hole in it. There's room in the back. I don't mind if you grab a knee for the test, as long as it's you moving away in like a claustrophobic situation. You're not just being like, hey, buddy, let's take the test together. But a couple of you are in tight quarters-ish. So if you want to move to the last row, move to the back, that's okay. Pick your spot, clear your desk, pencil, blank piece of paper, you're ready. Does that sound good? Okay, so let's come back. Here's the test review. Let's go to the review itself. All right, what's going on? Section 1, quadratics, everything quadratic. If I were you, I would write down standard form. I give you an example problem, standard form. Isn't that where we had to complete the square? Is there another way to find the vertex without completing the square if you had an option like in a multiple choice? What's the baby formula? Besides completing the square, you can do h equals, h is the x of the vertex. You guys remember how to find h, the cheater formula? No? I'll just give it to you. H equals negative b all over 2a. There is a cheater way to find the h of the vertex. H equals negative b all over 2a. The other way is completing the square. You're going to have to practice it when you work on standard form in section 2.1. So the big thing from 2.1, standard form, vertex. Maybe axis of symmetry, how you steal the x of the vertex. Section 2.2. Section 2.2. We were talking about, they say transformation, that's not a huge deal. Leading coefficient tests, that's a good one. Polynomials, leading coefficient tests. Another way of saying that, if you want to like put a little key in your notes, leading coefficient test is asking about the end behavior. Asking about the end behavior. For instance, if you have an even degree, what does that mean? X to the 4th, x to the 6th, x to the 8th. What's going on at the ends? Same. Just depends, right? Positive leading coefficient, they're both. Negative leading coefficient, they're both. Okay. How does the wording work? It could be rising to the right, rising to the left, falling to the left, falling to the right. That's even. They go together. How about odd? Positive leading coefficient, right? Falling to the left and rising to the right. But what if it's a negative leading coefficient? Now, were there some snazzy ways of writing that with like arrows and f of x's and things like that? I wouldn't ask for the snazzy notation unless it was a bonus. Okay, section 2.2. 2, what else did we have? We found zeros, so we were practicing with factoring. We just got introduced to the sign chart. We would put in our zeros, and then we would go ahead and find a few extra points, and then we would get the general gist of a curve. Normally, I would say 2-2 sketching would be a great long answer, but we got a better sketching long answer in section 2-6. So let's stick with the 2-6 long answer sketching problem because it gives you more things to find with all the asymptotes and the vertical, horizontal, oblique, along with the domain, intercepts, etc. So kind of this is good long answer, but 2-6 is better. Intermediate value theorem. If there is anything on the test to do with it, there might be one multiple choice. Long story short, just in case this starts to scare you, intermediate value theorem, if you plug in and get a negative 1 second, and then plug in something else and get a positive, what do you know has to have happened somewhere in between? If your y's go from below to above or above to below, they have to go through. Maybe bouncing, maybe going through. But they have to have a 0 somewhere. That's the long story short. Section 2-3, you guys liked this homework because it was long division and synthetic. It was long division and synthetic. Remember if any terms are ever missing, which I don't see any missing right now, but remember to put your zeros if anything's ever missing, right? If an x squared term is missing, put a 0x squared, whether you're in synthetic or long division. One of the things you guys got a little bit stuck on in your quizzes, remember the quizzes I passed back? You can study those for tomorrow. A few of you guys got confused about the remainder theorem. When you do synthetic, the remainder equals the function value. There might be one on that tomorrow. But the remainder is the same thing as the function value. And then remember when you do synthetic, guys, what do we put in the box if we were to do synthetic division with this guy? -6. Good. And then the pattern is you bring down and then you multiply, add for synthetic. Ooh, for long division though, aren't we subtracting because it's division? What do we have to remember and be very careful of when we're subtracting with long division? Distribute that negative, right? Then section 2-4, actually you guys did pretty well in that homework too. You didn't like the division as much. If I were you, I'd make a note of studying the division in 2-4. When to multiply by a conjugate, when just to multiply by I. And the other thing that you guys tend to get a little bit confused is what to make I squared, how it's -1. But otherwise, just be careful of your seals if you're just distributing negatives. Combining like terms, remember every complex number is a plus bi. A is the real part, or A equals the real part. B equals the imaginary part. Real quick, how would you rewrite this guy if you put an I in there? What would it equal? 10i. Plus or minus 10i? No, it's just plus, but 10i. Just making sure. Section 2-5, what was going on? Okay, this is since the quiz. Since the quiz, 2-5, 2-6, 2-7. 2-5 said, factor anybody. 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 Those of you guys that have the review written down, what problems did I give you around 30 and 40s? What did I give you? If I were you, I'd make a note of very carefully practicing with 41. I would highlight that one, number 41 in the review. Kind of like you're highlighting the sketching the rational from section 2.6. Why? It's a great problem to see if you understand section 2.5. Do you know how to list out your possible zeros? Do you know plus or minus factors of the last over the first? Do you know how to test 1 and -1, 2 and -2 to find a 0 to then do synthetic and break it down? That's a great problem. What, Matthew? I guess it could be either. Maybe it's both. But I don't think they'd both be as hard. And maybe one of them would have a clue like 2.5 gave you about like, oh, hey, by the way, this is one that you should already start with. Does that make sense? That would make it go a little faster. Remember, no Descartes-Wolf signs, no upper-lower bounds. None of that is on the test. And I don't think really the directions get too tricky. In this homework, there were some tricky directions as far as irreducible over the blah, blah, blah. That's not there either. But if they ask for factors, if I ask for factors, do I want x equals or do I want parentheses? Factors. Okay, factors are the parentheses. Zeros are the keep going to get x equals, right? Section 2.6 is everything to do with rational that we just graded. What happens when we have fractions? Vertical asymptotes are the zeros of the bottom. Wait. They're not the only zeros of the bottom. Who are the guys we have to watch out for if I ask you for vertical asymptotes? Who else hides in the bottom? Holes. How do we tell the difference between holes and vertical asymptotes? You factor it and reduce. The holes are gone. Who's left? Vertical asymptotes. How do you do horizontal asymptotes? Check the top and bottom. Who wins? Do some of you need to study your degree tests? Make sure you have them. What do you do when top wins, bottom wins, tie? What happens when the top wins by 1? Who could you find? The oblique asymptote by long division. Ignore the remainder. And then we already talked about 2.6. We already talked about 2.6. A sketching problem is a great thing to study. Last but not least, 2.7. Last but not least, 2.7. I've already told you there's going to be one multiple choice and one long answer. I've already told you to study one like 62, but let me have you also study one like 59. Okay? An easier one and a harder. Ooh, wait, this is kind of easier, except maybe study one like 60. He might be a little too hard, because you would have to subtract the 2 and have this weird 12. To be honest, I would say probably study something more like number 60. Does that make sense? Okay. Guys, that's chapter 2. Starting from a quadratic and ending with polynomial and rational inequalities, there's a lot to study. There's a lot to work on. But some of you guys were able to start working on the review already. So is there anything that someone's already like, I'm stuck on this review problem. Can you help? Seniors, we okay? Underclassmen that already started, we okay? All right, then here's what I'm going to do. You guys have already written down your review. Guess what? I have the beginning problems up. So some of you are already working. Take the next 4 minutes to keep working. Some of you guys haven't started. Why don't you go ahead and start with your first review problem, which I think is number 3? Sorry, I didn't memorize it. What was the first? Oh, number 1, then number 7. Lo siento, I wasn't even close. As you guys think about how number 1 has transformed, just like vertical flip, shift, I'm going to do number 7 on the board because number 7 is asking for completing the square. And some of you are like, oh, I would love to see another example of that. So I'm going to go ahead and do number 7 on the board. If you want to write it in the back of your homework spiral, that's totally okay. Those of you guys that were absent yesterday, you didn't get your, or 2 days ago, you didn't get your quizzes, and you might want to just peek at them to study them for tomorrow. You can come ask me about them if you want. We'll talk about life a little bit later. But for the rest of us, I'm just going to play with number 7. But you'll be working out what's most helpful for you. Number 7 says get into standard form. Plus 13. Quick reminder, standard form is that guy with a times x minus h squared plus k. I need to get this 4 out. So I'm going to separate these guys. I'm going to get a leading coefficient of 1. Only taking away from the x terms. Can anybody help out? Why did I put a 4 blank to offset this guy? Yeah, I need it to be equal, and there's a 4 outside. Do you remember how we get that spiffy number to put in the blank? We take b, we cut him in, and then we square him. So he's going to be 1/4 and 1/4. The really cool thing about factoring, completing the square, if you've done it correctly, you could do an x method if you want. What factors of 1/4 combine to be 1? You could do x method. Hopefully you'll get 1/2, 1/2. Or you can just steal this inside number every time and say x, what's the sign? Well, it's a positive number. Okay. So plus. All we have to do out here is combine these two. I see the 4 over 4 reduced, and 13 minus 1 is 12. What can I tell about this guy? Who's my vertex? Careful. Negative 1/2. X minus h. Negative 1/2. K is 12. But could you have done your little cheater trick to make sure you were right in the beginning? Negative b over 2a. Who is your b at the very beginning? Negative with 4. And then 2a would be 2 times 4. Oh, sweet. That is negative 1/2, right? But what's the only way you would have been able to get k? Plug in, or just complete the square. If you want a picture of completing the square, this is a pretty good one, and it'll help you with your test review. I'll be here during lunch. I'll be here period 7. I'll be here until 3:30. If you need something, come find me. Bye, guys. You got this. And if you can get it done, you have a weekend completely free of math. A long weekend completely free of math.